Hello. Today we're going to talk about the dial caliper. It's a precision measuring tool, and it is more accurate than the rule that we first learned about. So we're going to talk about this. I have a PowerPoint that we're going to work through, and then I have a little video at the end. So I'm going to make myself small so we can start this up. So the dial calipers. It's very versatile because it can measure in multiple ways. Not to be confused with some tools that really can only measure one way, and I'll show you what I mean here. At any time, if there's a slide that you're trying to read the information, I'm not going to read word for word, so just pause me, read the information, and go on. But I'll just kind of give you an overview of the slide. This PowerPoint was used from Project Lead the Way. I teach Project Lead the Way, and found that this is a really decent introduction to the dial caliper, so that's why I'm going to use it. So there's an isometric view of the dial caliper, and there's 4 different ways you can use it to measure things. So here are the 4 different ways that you can measure with it: outside diameter, inside diameter, step, and hole. So hole, inside, outside are the 3 most common ways. Step distance is used a little bit less often, but it is still very effective under certain kind of situations. So these are the jaws, and on these jaws, this is where you're going to use to measure outside. These jaws have faces. It's thicker up here and it's thinner down here, so if you need to get into spots that are kind of tight fit, it makes it really useful. So that's outside measuring, and here's an example of measuring on the outside with the dial caliper. Inside measuring, you're measuring with the outside edges of this, and you're sticking it inside a hole or a slot in order to get the numbers. Now the numbers that you read on the dial and all that, which I'm going to show you in a minute, is all read the same way. There's no adjusting or compensating. It doesn't matter which way I'm using the tool. It's all read the same way, which is a really nice feature. So here's an example. Here's a hole, and they're measuring the inside of the hole so they can measure the diameter of the hole. Step measuring, it's a little bit tricky looking on this, but you put this down on part of it, and then you go along this, which runs along the back side of this, and the distance between there and there is what you're reading. So here's an example of that. See how that kind of is behind? That is connected to this, so when this moves up and down, this goes with it. And depth, measuring the depth, whether it's the depth of a hole or the depth of a step. Notice how this is really narrow. It makes it easier to get into a small spot, whereas trying to get this up in here to measuring it with the step, like on the last slides, it wouldn't be possible in some cases. So here's an example of that. This is extended down, and you have to be flat on this at the top surface in order to get an accurate measurement. So terminology or nomenclature in the way that it works. So typically this dial, typically this whole thing goes 6 inches. Most the ones that we're going to use are 6 inches. They have larger ones. They cost a lot more. But as far as holding on to it and using it, a 6 inch is plenty big enough for everything we're going to do. And that means from all the way closed to open, it's a little bit more than 6 inches. So on the back side is what they call the blade scale. And it shows each inch. So this big number's inch, 3 inch, 4 inch. Okay, each inch is divided into 10 increments. So in manufacturing, we talk about things in terms of thousandths of an inch, 0.001. So in this case, this 0.100 If you didn't even look at that 0 point, it would be 100. So that's 100 thousandths. So we talk in terms of thousands. So each one of these is 100 thousandths. So 100, 200, 300, and so on. 900 thousandths, 1 inch. 1 inch, 100 thousandths. So that's kind of the way you're going to work this. So here's that blade that they were showing on the last slide. It's on the back. That doesn't move. What moves is this top part with this other jaw. This is the movable portion in here. They call it a slider. Inside here are gears, and there's a gear rack here on right below the scale, and that's how this thing is able to go accurately. It moves back and forth. Unfortunately, the gear rack is made out of the gear rack is steel, and the gears are made out of plastic most of the time. So if you let this thing lay on the machine and you're cutting and chips fly and chips land in here and you open and close the slider, the chips get stuck in here and they ruin the gear, and then the calipers are no good. So when we're working on the machines, we want to make sure that we put the dial caliper in the case, close the case. Then when we cut and chips fly all over the place, it really doesn't matter. Brush them off, open it up, and the caliper's good. So this pointer, the needle, is like on a clock, a hand on a clock, is going to go around this circle. Most of the dial calipers, one full turn equals 100. So this is 10 thousandths, 20, 30, 40, 50, 90 thousandths, and it's 100. So one full revolution is going to move like from 3 to 400 thousandths, okay? This is the reference edge right here. On a dial caliper, you must look at where the edge of the caliper goes across the scale. And I want to show you a difference in a different type of caliper. If you look at this, this is not coming up to the scale. It jogs over and it comes up. This is the part that's going up by the scale. So this is my visual alignment to say this is 1 inch, 400 thousandths, plus what's on the dial, 76 thousandths. I'll better explain how to use that measurement, but I want you to really see that this line right here is, since that's the part that's crossing on this scale, that's what I need to look at. On this caliper, it's straight. And it depends on the manufacturer whether it's straight or whether it jogs over like the other one. Important thing is you need to know which is going up against the scale, okay, where the numbers are. So this is the rack. The rack's where the gear is. It's a gear tooth, and that's how it moves. So how to read it? It's divided in 100 times. Again, 100 thousandths each time. Each time it moves 100, it goes 1 revolution. I will tell you that there are some dial calipers that between here and half a rotation is 100, and between other half is another 100. Most of the ones that we have are like this, 100. So you always got to look at the numbers and see, does 100 down here, or is this 90, and so I'm assuming 100, or does it go count around like this one and back to 0 is 100? Okay, so each one of these lines here is 1/1000th of an inch. The little dot in between the two lines is a half of 1/1000th. Not now, is a half of 1/1000th. So really it's just a 5 at the end of this. So if I were to add 2 of these together, I would get 1/1000th. A half a thousandth and a half a thousandth is 1. Okay. So every time the pointer completes a full revolution, it moves 100 thousandths. So here they're measuring the outside of this pipe. We're looking at the blade scale. We look, and the first thing is how many inches, and write it out, 1.000. How many hundredths? 1, 2, 3, 4. I can see the 5 there, but this has to go past the line. See how it's past the line on the 4 here? It's not past the line on the 5, so it's 400 thousandths. Notice they're keeping the decimal points all aligned so that we don't have an addition problem here at the end. Next order of business is how many ones are on the dial here. If we look at this, it looks like 37. Yep, 37. Then I'm going to add these up, and I have 1.437. If this doesn't make sense, I want you to stop right now, back up a little bit, and re-look at this until this makes sense, okay? All right, moving along. So, here's your practice. So, I want you to say, I want you to figure this out. So what I want you to do is stop the video, and I want you to try and figure it out, and then come back and press play and see how you did. Okay, let's see if you got the right answer here. So, how many inches? 1 inch. How many hundredths? Look at that. Looks like it's just barely past that line. 400. How many thousandths on this needle? Where is this pointing? 2 thousandths. Add them up. 1.402. I hope you got that answer. Okay, so hopefully that video helped to expand your understanding a little bit and clear things up if you're a little bit confused. What I have that I'd like to share with you is a website that you can actually practice and get some more work with. So I'm going to make myself small again. So if you search virtual dial caliper, Stefanelli is the name of this guy, this professor who does virtual measurement tools. Makes a simulator. So I can scroll down. There's a caliper. I must have made my screen big. Let's get that back down where it belongs. Okay, so there's my virtual caliper. If I keep scrolling down, here's a picture of one that's moving along. So if I just pick on it, here it makes it big. If I drag this, I can move it to a specific position. So I could pick a number. Let's say I want to do 2.375. I can move this 8, 9, 2, what did I say, 2.376, 100, 200, 300. See, there I'm lined up on the line at 0. Come around some more to about 376. You might not get exactly perfect to 1,000 because it's kind of hard to move it, but then it tells me what the number is. If you want to practice, you can cover up the bottom of your screen and move it to a number, try and figure out what it is, and then uncover the bottom part of your screen and see if you got it right. I've tried zooming this. It didn't seem to want to work. It used to. Let's see, I'll control zoom. See, I do, but it comes back. So I don't have an answer at this point in time on how to make it so you don't see the number here. So I would just say put a piece of paper up there on the screen for practice. And this is only if you want to get a little bit more practice. It does make it easier. The more you practice, the more you see it. So that's all I have for dial caliper, and we'll see you next time.